Hello everyone, hope you are doing good. I welcome you back to a new session. So today is the fifth lecture of our transition course. So in the first two lectures we talked about functions, and in the third and the fourth lecture we talked about trigonometry. So in the fifth lecture today we are going to talk about straight lines. And straight line is a very important topic in with respect to physics. Okay, why it is very important? Okay, first of all let's understand why it is so important. So generally what happens that a variable, let's say an acceleration, is given as a function of time, okay, or velocity is given as a function of displacement, right? And the equations are given or the graph is given and we have to find the equation. So generally what happens that we have to write the equation of the straight line to find the equation. Okay, so I think you are not understanding what I am trying to say right now, but later on you will understand that what does that mean. So without any further ado, let's start. Okay, let's start with straight lines. So first of all, let's start with Cartesian plane. What is a Cartesian plane? Okay, so I will give you a very small example, right? So let's suppose if I want to give the information about my location, right? So let's say right now I am in Hyderabad. Okay, I am in Sri Chaitanya Academy studio and I want to give my location, right? So to give my location, right, what is the information I will give, right? So I will say that okay, I am in Hyderabad, right, in India, and okay, so in Asia I will also specify the continent, right? Or also if I want to specify to some alien, I will say okay, I live on planet Earth, right? And I can go on like this, right? No, so this is what so that is the specific location of me, right? Or in other words, if I want to specifically, right, tell my location, I can say the latitude and the longitude. No, so to specify my location, we use latitude and longitude. Correct? Latitude and longitude. So now we are talking in terms of maths, no, in physics. So in physics, to locate anything, okay, what is the first thing we do? Okay, so first of all we need a reference. Okay, we need someone who will tell me about everything. He will observe everything and tell me. Okay, so let's say that first of all we need to define some axis. Okay, why some axis? So it is like Earth, no? So on Earth, right, we draw the latitudes and the longitudes, and the equator is the reference, right? Equator is the reference. Similarly here, for this is known as a Cartesian plane. Okay, if I make the x-axis and the y-axis, okay, if I make the x-axis and the y-axis, so I can specify the location of a person. Okay, I can specify the location of any object in this two-dimensional plane. Remember, we defined this Cartesian plane for 2 dimension. Okay, this is for 2D. Okay, 2D means there are two axes. How many axes? X-axis and a y-axis. So why it is 2 dimension? 2 dimension because I will specify 2 coordinates of a particle. So let's suppose if I have a particle somewhere here, right? So let's come to this point. So let's suppose if let's look here only. So let's suppose if a particle is kept at this point or a person is standing at this point, right? So what are the 2 coordinates or the locations? So if I want to give the location about this particle, yes, I will ask a person, right? I will ask a person who is sitting at this point. Okay, a person is sitting at this point, and who is this? He is the person who observes everything, who looks, right? So he is the observer for us. Okay, and he will observe everything for me. So I will ask him, okay, so where is particle P? So what he will say? Okay, the particle P as it is at this point, right? So we will locate. So this is how he is locating. But now I want to give the location. No, he will point me in this direction. So what will he tell? He will tell me that you have to walk x units, right? Let's say x units in this direction, Okay, you walk x units in this direction and you walk y units in the above direction. Correct? So what he will tell me? Okay, what do we tell? No, that you go straight and then take a right. So same thing here. You walk x units in the x axis and y units in the y axis. Okay, what is x? X is just a distance, y is also a distance. Okay, so same thing. So if this length is y, can I say that this length is also y? Right? This length will also be equal to y. So I can say that to reach at this point P, I will have to walk x units along the x axis and y units along the y axis. So what I have done here? I have basically specified the location for my point P. Okay, so this is for a 2D object or a 2D plane, right? So it is not, so if let's suppose if this is a plane, no, this screen is a plane. So if I keep my hand here and if the origin is somewhere there, right, I can specify the location. But let's suppose if the point is kept somewhere here in 3 dimension. So let's understand this room. Okay, in your room you go and pick a corner in your room, right, and you are somewhere, right? So you, if you want to find the location of yourself, right, who will tell the location? The person who is sitting at the origin. So in 3 dimension, right, what are the axes which I have? I have x axis, I have y axis, and I have the z axis. Okay, so what is this? Is the x axis, this is the y axis, and the z axis is pointing towards you. So if you see, this x and y axis will make a plane, right? This x and y axis will make a plane. But if this z axis which is pointing towards you, okay, so plus z axis is pointing towards you, minus z axis is going inside. Okay, clear? So with the z axis, okay, our 2 dimension will become 3 dimension. Basically we are changing from 2 dimension to 3 dimension. So now to give the location of any object, right, what do we need? We need 3 dimensions, right? In 2D we need 2 locations. In 3D we need 3 coordinates. What are the coordinates? Okay, so what is x? X is a coordinate. What is y? Y is a coordinate and z is a coordinate. So in 3D, if an object is kept here, right, so what I will say that the location of this particle is x, y, z. Okay, so for now let's understand what is this location, what is this location in 2 dimension. Okay, let's move forward. So distance formula. Okay, so now this distance formula, if we talk about this distance formula, what is distance formula? It gives me the shortest part between 2 points. Okay, so distance formula, let's write it here. It gives me shortest path between 2 points in a, okay, so let's say it gives me the shortest path. So now what do we have? We have 2 points here, right? P x1 y1 and q x2 y2. Okay, so let's specify. Okay, so for this first point, right, what is x1 y1? So x1 is the distance traveled in x direction, and what is y1? Y1 is the distance traveled in y direction. So this will be y1 and this is x1, right? So how did we reach here? I will reach here by walking x1 distance along the x axis and y1 distance along the y axis. Okay, so this is how I am going to reach the point 1. Now let's go to point 2. So how to reach point 2? To go to point 2, yes, I have to walk x2 distance. I have to walk x2 distance along the x axis, right? That is why the x coordinate is x2 and I have to walk y2 distance along the y axis. Okay, so you should not be confused with what x2 is, what y2 is. Okay, x2 and y2 is basically specifying the location of the point Q. Correct? So now once I have the location of point 1 and 2, okay, so basically you understand here what they have done. Okay, they have basically made a triangle here, this small triangle, if you can look here, right? So what do I need now? So to calculate this, what is the shortest distance between them? Point 1 or point P and point 2 or point Q, if I connect them with a straight line. So can I say for this triangle, this is the hypotenusis, right? And since this is hypotenusis, right? Okay, now what can I say? What is this? So now, so in a triangle, yes, if I want to calculate this H, right? What do I need? I need the perpendicular and the base of the triangle. So what can I do in that case? I can say that H square is basically equal to P square plus B square. Correct? So now how can I find perpendicular? So what is the perpendicular? This is the perpendicular, no? So perpendicular you can easily find by taking this y1, y2, sorry, this is y1, right? And if I remove this y2, right, this is my y2, correct? This length is y2, this length is y2. So from this y1, if I remove this y2, I will get this length, and what is that length? That length is y1 minus y2. Similarly, if you look here, what is this length? This length is x2, right? This red length is x2. And if I remove this x1, what I'll get? x2 minus x1. So basically I have that what is my P? P is y1 minus y2. And what is B? B is x2 minus x1. So now what I'll do? I'll just substitute the values here, okay? And once I substitute the values here, what I'll say? I'll get H, okay? H square is basically P square. What is P square? P square is y1 minus y2 whole square plus, here what is B? B is x2 minus x1 whole square. Okay, so now what is H? H is, now what is y1 minus y2? It is delta y. Okay, what is delta y? The change in the y coordinate plus, now what is x2 minus x1 whole square? If you look very closely, x2 minus x1 or x1 minus x2 whole square is the same thing, no? Because it is square. So I can say this is also delta x whole square. Okay, so under root. Why under root? Because I am removing the square here. So this is the distance formula. Okay, so to find the distance between any two points, we take the difference of the coordinate squares. Okay, difference of the coordinate square. But what if I have a third coordinate, right? And what is the third coordinate? Let's suppose if I have the z coordinate as well. So in that case, okay, in case of 3D, this is in case of 2D. In case of 3D, the distance d, okay, the distance d, you can say that in case of 3D, okay, distance d is equal to delta x square plus delta y square plus delta z square under root. Okay, so this is in case of 3D. Very important. Okay, so I hope you understand what we are trying to do here. So distance formula is also easy. Let's move forward. Now, so what is a polynomial first of all? Okay, so what is a polynomial? Polynomial is a finite length expression of the form a0x0 plus a1x1 plus a2x2 plus till, and it goes on till how many? So see how many numbers are there. Okay, if you see, I have started from 0. I have started from 0 and I am ending at n minus 1. So can I say there are n terms here, right? There are how many terms? Okay, sorry, I made a mistake. I am ending at an, right? So there are n plus 1 terms. Okay, n plus 1 terms. Correct. So if you look here, right, so you tell me that if I write this much a0 x0, okay, let's say if this is the polynomial, okay, if this is the polynomial, and all the other terms, okay, all the other terms a1 equals to a2 is equals to and so on is equal to an is equal to 0. Let's say if this is the case, okay, if this is the case, then can you tell me, just 1 minute, okay, so let's say if I have something like this, if I have something like this. Okay, so what are the terms that are left? Okay, I only have this, the first term left, right? Otherwise a1, a2, everything is 0. So in that case, what this becomes? This will becomes a0. And what is x raised to 0? X raised to 0 is 1. X raised to 0 is 1. Correct? So what is this? Right? This will become a0. Yes or no? Right? And this is constant. This is constant. So this is just a constant term. So when we are talking about this, when the coefficients, okay, what is this? This is the coefficient. So when the coefficient of x1, x square, all the other terms is 0, we'll have a constant term. Okay, now let's move forward. What if, let's say that if we have a0, x0 plus a1, x1, okay, they are not non-zero, but a2, a3 and so on till an are 0. Let's say if all the other terms are 0 here. So in that case, what do we have? We have a0, and this is, right, x raised to 0, x raised to 0 is 1 plus a1x, right? So what is this? This is a polynomial, no? This is also a polynomial, but here the coefficient is x. So this is a polynomial of degree 1. Okay, that was a constant, and if you will later see that this is a straight line. Okay, this is a straight line. Now let's talk about a quadratic equation. So you might have learned quadratic equation. So now tell me, for quadratic equation, what should be the coefficients here? So for quadratic equation, if you think nicely, right, these powers, okay, a3, a4, a3, a4, a5 and so on till an should be 0. Okay, so what I'll have, a0, x0 plus a1x plus a2x square. Okay, so this is a polynomial with degree 2, or this is known as a quadratic equation. So don't worry, we'll talk about all of them. Okay, we'll talk about all of them. So basically we'll first study about straight lines and then we study about the quadratic equation. So I hope you understand what a polynomial is. Okay, next, so general form of a straight line. Okay, so now we begin with straight line. What is a straight line? So for a general form of a straight line, so how do we draw a straight line? First question. Okay, to draw a straight line, what do we need? We need 2 points. No, 2 points, point 1 and point 2, and the 2 points are connected. So let's say, let's make 2 points. Okay, this is point 1 and this is another point P2. Okay, now if I join these 2 points, right, if I join these 2 points, we will get a straight line. Okay, so now for this straight line, this one, right, let's remove this. Now, so this is my x-axis, this is my y-axis, and this is my straight line. So let's say it is passing through 2 points P and Q. Okay, and I'm naming the points. Okay, so let's say this point has location x1, y1, and this point has a location x2, y2. Correct? Now, so general form of a straight line. So what is the, so let's first write the general form of the straight line. What is the general form? Y is equal to mx plus c. Okay, y is equal to mx plus c. So what is y? First of all, what is y? This is the y coordinate, which lies on the straight line. Okay, what is x? This is the x coordinate. Which lies on the straight line. So basically what is x and y? So any point, let's suppose if I have a point, right, and this point is lying on this straight line, no, let's say a point is lying on a straight line. So to give the location of this point which is lying on this straight line, yes, what I'll say, the location is x comma y. Which point is lying on the straight line? X comma y. Clear? So okay, now we know what is y, now we know what is x. But what is m? Okay, what is m? M is known as the slope of the straight line. Okay, what do we call m as? M is known as the slope of straight line. Okay. So what does slope tells us about? Okay, so slope tells us that how tilted the line is. Okay, and basically we say dhalan, no? So what is the slope of the straight line? Okay, so this is basically telling the inclination, okay, the slope of the straight line. And how do we measure the slope? We'll talk about that later on also. Okay, and what is C? C is the y-intercept. Okay, so what is C? C is y-intercept. So basically it tells us that where it is cutting the y-axis. Okay, where it is cutting the y-axis. So what is y-intercept? The distance between the origin. This origin is 0, 0. Okay, this is known as the origin, where both x and y are 0. So this origin, and this is the point where it cuts the y-axis. So if you find the distance between them, okay, if you find the distance between them, this is known as my y-intercept. Clear? So now you should know that what y is, what x is, what y-intercept is, and what is m? M is slope. So now what are we left with? We should know how to calculate slope first of all. Okay, we should know how to calculate slope. So let's first understand how to calculate slope. Okay, so let's say this is my axis. Okay, this is my x-axis and this is my y-axis, and I have a straight line. Okay, so let's say this is the straight line. Okay, this is my straight line. So first of all, how to find the slope? Okay, how to find the slope? So first of all, you locate the point where it is cutting the x-axis. I will locate the point where it is cutting the x-axis. So I have located the point. Okay, then from that point I will always draw a line along the positive x-axis. Okay, so what is the first thing? Okay, locate where the straight line cuts x-axis. What is second step? Extend the point P, the point along positive x-axis. Okay, so what I have done, I have extended the point along positive x-axis. Now, third, you start from here, right? You start from the this line along the x-axis and you rotate anti-clockwise. Okay, you rotate anti-clockwise till you reach the straight line. Okay, so what is the third point? You start from the extended straight line and move in an anti-clockwise till you reach the straight line. Okay, so basically what we have done, we have, okay, so let's look at the points. Locate where the straight line cuts the x-axis. So I have located the point where it cuts the x-axis. Then extend the point along the positive x-axis. I have extended the point along the positive x-axis. You start from the extended line and move in an anti-clockwise direction till you reach the straight line. So I start from this extended straight line and I move in an anti-clockwise direction till I reach the straight line. So now this angle is known as theta. This angle is known as theta. So what is fourth? The angle between straight line and the extended line is theta. Okay, so now what is slope? So what is slope? M, right? I told you M is the slope. And what is M? M is tangent of theta. M is tangent of theta. So this is how you find the slope. Okay, so to find the slope of a straight line, you have to do this exercise. Okay, so this is how you find the slope. Let's move forward. So slope intercept form. Okay, what is slope intercept form? So what do you need? You need a slope. Okay, you need a slope M. What do you need? You need an intercept. Okay, you need an intercept. So to find the equation of a straight line, what do you need? You need a slope and you need a intercept. So let's make a straight line. This is a straight line. So what do you need? First of all, so basically I will find the point where it cuts the straight line. I will draw a line along the x-axis, and then from this extended line I will move toward the straight line, and this angle is theta. Then I will find the y-intercept. What is the y-intercept? This is the y-intercept I can see. I can say C. Right? So to write the equation of slope intercept form, I can say y is equal to mx plus c. Okay? So this is the basic slope intercept form. So in this equation, okay, in this equation of a straight line, okay, this is the general equation of a straight line where what is y? Y is the y coordinate, m is the slope, x coordinate, and c is the y intercept. So I'll just write it again. What is m? M is tan theta, or I can say this is the slope. What is c? C is y intercept. Okay, clear? Now let's move to the next part. Slope and intercept. Okay, so I have already done that what slope is, right? How do you find slope here, and what is the intercept here? So let's just again revise that. What is slope? Slope is m, and that is equal to tan theta. That is equal to tangent of theta. So, and what is the, how do you find theta? So to find theta, first of all, you look at your straight line. So let's now make some different straight line. Let's say if I make a straight line like this. So in this scenario, how will you find theta? So again, let's follow the points which I have written. So what are the points I have written? Locate where the straight line cuts the x-axis. So I will locate the point where it cuts the x-axis. This is the point where it cuts the x-axis. Correct? Now, next, what is written? Extend the point along the x-axis. Extend the point along the x-axis. So, okay, I will extend this point along the x-axis. So I have extended this point along the x-axis. Okay, now you start from the extended straight line and move in an anti-clockwise direction till you reach the straight line. Okay, so let's, what he is trying to say? He is trying to say that you start from the extended straight line and you move in an anti-clockwise direction till you reach the straight line. Correct? So this is what we have done. You start from this extended straight line and move in a direction till you reach the straight line. So I have started from the extended straight line and move in an anti-clockwise direction till I have reached the straight line. Then what is the fourth point? The angle between the straight line and the extended line is theta. So this angle is known as theta. Correct? So this is how I am able to find the theta, and once I am able to find the theta, right, I can easily find the slope. So I hope this point is very clear to you. Okay, now let's move on. What is intercept? So if I have something like this, okay, if I have something like this, and let's say this is the straight line I have. So what is, how many types of intercept I'll have? I have two type of intercept here. Okay, so what is this? First of all, this is the origin. Okay, this is the origin, and the origin is 0, 0, right? Then what is this point? This is the point where it cuts the y-axis. This is the point where it cuts the x-axis. Okay, so at this point, can you tell me what is the y coordinate? Y coordinate will be this y coordinate, and what is the x coordinate? 0. This is 0, y, and this point will be 0, x. So the distance between this and this is known as y-intercept. What is y-intercept? Y-intercept, I can say that y-intercept is distance between origin and the point where it cuts the y-axis. Okay, next, what is this? This is distance between origin and the point where straight line cuts x-axis. Okay, so now you should know that what is x-axis and what is y-axis. I hope this is clear to you. So now we know that how to calculate slope, what is slope intercept form, how to find slope, right, how to find the intercept. Great, let's move forward. So let's do a question, right? In this question it is given that find the slope and intercept of the equation of the line 2x minus y plus 5 equals to 0. So what is the equation given to me? 2x minus y plus 5 equals to 0. So this is the equation of the straight line given to me. And what do I have to find? I have to find the slope and the y-intercept. So basically I have to find m and I have to find c. Okay, so now let's find, so let's first of all write this equation in the general form. So what is the general form? So general form is given as y is equal to m x plus c, right? This is the general form. So let's first make this equation in the form of in the general form, right? So basically I will take this y here. So what do I get? I will get 2x plus 5 is equal to y, right? Or I can substitute I can write this y here, right? I can just write this y here. So what will this become? This will become this. So this will become y is equal to 2x plus 5. Okay. So now if I compare my coordinates, okay, if I compare the coefficients, right? So y is y here, what is m? So from this I can see that m is equal to 2 and here c is equal to 5, right? So I am able to calculate the slope and the intercept of my straight line. Okay, let's move to the next question. With the slope 6 and y-intercept 4. So what is given? Slope m is equal to 6 and y-intercept is equal to 4. Find the equation of a line. Okay, so now when slope and intercept both are given, which equation will I use? Okay, I will use slope intercept form. Okay, I will use slope intercept form. So what is the equation of slope intercept form? Y is equal to mx plus c. This is the general equation of the straight line. So let's put here y is equal to, now what is m here? M is given to me 6x plus, now what is c? C. So okay, sorry, I have written this wrong. What is this? This is c. Intercept is c, right? Intercept is c. So y is equal to mx plus c, and what is c? C is 4. So this is the equation of a straight line. Okay, so this is that easy. Okay, if you are able to find the slope and the intercept of a straight line, you can just find the equation of the straight line. That is nothing difficult here. Okay, now let's move to the next part where we need slope and point. Right? So what do you mean by slope? Slope is m basically, or I can say m is basically equal to tan theta. Now what is point? Okay, so when I say point, basically this point, this refers to a point which lies on the straight line. So basically, let's suppose if a point, so let's draw it first. Okay, so this is my straight line, and a point P, x comma y is lying on this straight line, correct? So let's name this point some other point. Okay, I want to name this point P as x1 y1. Okay, I will name this point P as x1 comma y1. Okay, a specific point P. Okay, you can say this is 3 comma 4. Simple. 3 comma 4 lies on the straight line. So now if this point P lies on this straight line, and let's write the general equation. What is general equation? Y is equal to mx plus c. Okay, so if this is a general equation, what can I say? That since this point P lies on this straight line, if I substitute the value of x as x1 here, can I say this y should be equal to y1? Yes or no? Because corresponding to x1, yes, y should be y1 here, because this is the point P which lies on the straight line, correct? So what do I get? I get, so through here I can easily find the value of c. So what is c? Y1 minus mx1 is equal to c, correct? I have this. So now what I'll do, I will substitute this value of c back here in this general equation. So what do I get here? I get y is equal to mx plus c, and what is c? C is y1 minus mx1, correct? So now let's take this y1 here. So what do I get? Y minus y1 is equal to m, now x minus mx1, and finally I'll get y minus y1 is equal to mx minus x1. So this is basically, if you look at this equation, right, what is y? Y is any general point which lies on this straight line, right? What is y1? Y1 is this particular point, okay, the y coordinate of this particular point P. What is m? M is slope, right? What is x? X is any random point which lies on this straight line. And what is x1? This particular point, or the x coordinate of the point P. So basically what do you need? You need any point x1, y1, and you need slope m. So if you have these two, right, you can write the general equation of a straight line. So what is the general equation of a straight line? In a slope point form, y minus y1 is equal to mx minus x1. Okay, this is the general equation that you should remember. So let's do a question. Write the equation of a line in a slope intercept form where the slope is -2. What is slope? M is equal to -2 and passes through the point 0, 9. So what is this? It passes through x1, y1, no? And that point is equal to 0, 9. So basically I have the slope and I have the coordinate. And since I have the slope and the coordinate, what form I can use? I can use slope point form. And what is slope point form? Y minus y1 is equal to mx minus x1. So this is the slope point form. Just substitute the values here. So what do I get? I get y minus y1. What is y1? y1 is 9 is equal to m. What is m? m is -2. x minus, what is x1? x1 is 0. So what do I get? I get y minus 9 is equals to -2x, and I'll get y is equals to -2x plus 9. So this is the final answer which I get here. Okay, so this is the equation of the straight line. I hope this is clear. Next, let's solve one more question. It is given, write the equation of a straight line that makes an angle 60 degrees with the positive y-axis. So let's first draw this. Okay, so basically what do you have? You have a straight line, okay, a straight line that makes an angle of 60 degree with the positive y-axis, and passes through 1, 3. Okay, so this is, let's say 1, this is 1, this is 2, this is 3, this is, let's say 1, this is 2, and let's say this is 3. Okay, and it passes through 1, 3. So 1, 3 will be somewhere here, right? So it passes through 1, 3. Okay, and it, so let's say, so let's make something like this. Okay, let's not, no need to, okay, you don't need the exact coordinates. Let's just, okay, now this point passes through 1, 3. Okay, and it makes a 60 degree with the positive y-axis. So if this is making 60 degree with the positive y-axis, this is my y-axis and this is 60 degrees, right? So do I need this theta? Do I need this theta to find the slope, right? To find the slope m, we need tan theta, right? Can I put theta as 60 degree? Can I put theta as 60 degree? No, I cannot put. Why? Because I know to calculate theta, I need the angle with the positive x-axis. This is not with the positive x-axis. This will be 90 degrees. So what is this? This will be 30 degrees, and this will be equal to 30 degrees, right? This will be equal to 30 degrees. So basically this is the point which I need, right? This is the angle which I need, 30 degrees. So what can I say? What is theta? M is equal to tan 30. Tan 30. And what is tan 30? Tan 30 is 1 by root 3. So I have the slope. So basically I have the slope and I have the point. So since I have the slope and the point, right, what is the equation I can write? I can say y minus y1 is equal to mx minus x1, where m is equal to 1 by root 3 and point is given as 1, 3. So y minus y1. What is y1? If you look there, y1 is equal to 3 is equal to m. Slope we have calculated 1 by root 3. And x minus, what is x1? x1 is equal to 1. So what do I get? Y is equal to 3 plus x by root 3 minus 1 by root 3. So finally we will get y is equal to x by root 3 plus 3 minus 1 by root 3. Okay, so this is your final answer here. Clear? So I hope this is clear to you. Okay, so basically what we have covered in this session, we have covered two parts, right? So first of all, we covered the slope intercept form. Okay, this is the first part, and the second part is the two slope point form. Okay, so in the next class we'll talk about 2-point form. Okay, and I hope this was a good session for you. Please join, subscribe, and please in the description box I have shared the Google form link and also the assignments for you. So please solve the questions, and if you have any doubts you can fill the Google form and ask questions. Okay, so I hope you enjoyed the session, and please join tomorrow at same time. Thank you everyone.